This set of notes is for solving equations and inequalities. And this should be a review for most of you guys. So, what we want to do is just look at a few problems and show how to solve them. First one. X plus 5 equals 21. Remember, we work our order of operations backwards if there's more than one. This one's just a one-step problem. It looks like the only thing that's been done to x is a 5 has been added to it. So we're going to subtract 5 from both sides. So we have x equals 21 minus 5 would give us 16. Remember, we want to make sure that we show the same steps on both sides of the equal sign. This was the equal sign. We showed our subtract 5 on both sides. Number 2, we have 32 minus r equals 16. On this one, we want to get rid of this 32. It's a positive 32, so to get rid of it, we're going to subtract 32. So we have negative r. Over here we have 16 minus 32, which would give us a negative 16. And then to get rid of that negative, we're just going to divide both sides by negative 1. So we have r equals 16. For number 3, we have 1/4 n equals 12. Remember, when we have something multiplied by a fraction, our first thought is to divide by a fraction. But we don't actually do division of fractions. We change it to multiplication by the reciprocal. So the reciprocal of 1/4 would be 4 over 1. So we're going to multiply both sides by 4 over 1, or the number 4. Over here, the 4's cancel and the 1's cancel, leaving us an n. Over here, 12 times 4 is 48. Number 4. We have 7x minus 2 equals negative 37. Remember, we said order of operations would be worked backwards, so we would think about our order of operation: parentheses, exponents, multiplication, division, or addition, subtraction. First, we want to take any add or subtract. So we're looking here, we have minus 2, so we would get rid of that by doing add 2 to both sides. So we have 7x equals negative 35. Then we would get rid of our multiplication division. This is multiplied by 7, so to get rid of it, we're going to divide by 7. So x equals negative 5. Number 5. We have 10b minus 6b minus 3 equals 9. Remember, we had practiced last year a long set of steps to ask ourselves what to do so that we could do this order of operations backwards. When we had our solving equations flow mat, first we did parentheses, and if it had parentheses, we cleared by distributing. Next, we checked to see if there were any like terms. Then we looked to see if there were variables on both sides. Then we looked for add, subtract, multiply, divide. So in our case, there's no parentheses, but there are some like terms. I have 10b minus 6b, which would be 4b, minus 3 equals 9. We don't have variables on both sides, so we're looking for anything add, subtract from the variable term. We have a minus 3, so we're going to add 3 to both sides of the equal sign. So over here we have 4b equals 12. Then we're going to get rid of any multiplication or division. This is multiplied by 4, so we're going to divide by 4. So we have b equals 3. Problem number 6. We have 5, open parentheses, x plus 3, close parentheses, equals negative 30. Since we have parentheses, we're going to use our distributive property to clear. So 5 times x is 5x. 5 times 3 would be 15. And that's equal to negative 30. We don't have any like terms. We don't have variables on both sides. So now we get rid of add, subtract. We have plus 15, so we're going to subtract 15 on both sides of the equal sign. So we have 5x equals negative 45. Remember, signs are the same, so we add the numbers, keep the sign. Then we're going to get rid of multiply by 5 by dividing by 5. So we have x equals negative 9. Problem number 7. Number 7, we have 5x minus 21 equals negative 2x plus 28. On this problem, we don't have any parentheses. On this side, we don't have any like terms. On this side, we don't have any like terms. We do have variables on both sides. So remember, we want to add the opposite of one of them to both of them. So I'm going to use the opposite of negative 2, which would be a positive 2x. So add 2x to both sides. Here's the equal sign, so I'm making sure I'm doing the same on both sides. Over here, I get 7x minus 21. Over here, the negative 2x and positive 2x cancel, leaving me just a 28. Then I get rid of anything that's added or subtracted. I have a minus 21, so I'm going to add 21 to both sides. So I have 7x equals, over here, when I add, I get 49. Now I get rid of anything multiplied or divided. I have something multiplied by 7, so I'm going to divide by 7. So I have x equals 7 as an answer. Problem number 8. Problem number 8, I have negative 3n minus 2, open parentheses, n plus 4, close parentheses, equals negative 6n minus 5. Lots of steps in this one. First, we're going to get rid of our parentheses by distributing. So we have negative 3n. We're going to take negative 2 multiplied times n, which would give us negative 2n. Negative 2 times 4 would give us negative 8, equals negative 6n minus 5. Next, we look for like terms. Over here, we have like terms. We have negative 3n and negative 2n, which would give us a negative 5n minus 8. Over here, we do not have any like terms, so we're just going to have negative 6n minus 5. We do have variables on both sides, so we want to add the opposite of one of them to both of them. Remember, if we're having positive numbers, then we want to pick the smallest one. If we're having negative numbers, we want to pick the biggest one. So this one would be the biggest negative, so we're going to add 6n to both sides. Over here, we're left with a positive n minus 8 equals negative 5. Next, we would get rid of our add subtract. We have subtract 8, so we're going to add 8, leaving us n equals positive 3. For number 9, we want to look at an inequality. We want 2x minus 3, which is less than 7 plus 3x. Now we're going to work this the same way that we work our equations. We just want a little bit of review with inequalities. We'll probably solve this and then graph it to show what our answer is going to be. So on this one, we don't have any parentheses, no like terms on either side. We do have variables on both sides, so we're going to add the opposite of one of them to both of them. So I'm going to take this smallest positive one, and I'm going to do minus 2x to both sides of the inequality symbol. Over here, those cancel, leaving us negative 3 is less than 7 plus x. Then I want to get rid of the positive 7, so we're going to subtract 7 from both sides. So I have negative 10 is less than x. Most people prefer to have the x on the left-hand side, which is fine. We're just going to write our negative 10 on the other side. Notice this is opened up towards the x, so we would open this one up towards the x. This is saying negative 10 is less than x. This one is saying x is greater than negative 10. Either way, when we graph that, here's our number negative 10, and we'll put some numbers around it as reference. It's going to get an open circle because there is no equal to. And it's saying x is greater than negative 10, so x is the part that we're shading. So all of this represents our x. So x is greater than negative 10, or negative 10 is less than whatever we're choosing as x. Any of these numbers could be x. So there's our equation, or our inequality, and here it is graphed. Let's look at another one, number 10. Number 10, we have 2, open parentheses, 4 minus d, close parentheses, minus 5d, is greater than 8. So first I would tackle my parentheses. So I would distribute. 2 times 4 would give me an 8. 2 times negative d would give me negative 2d. Minus 5d is greater than 8. Over here I have like terms, so I would combine these two. I have 8 minus 7d. Next, I would get rid of my 8. It's a positive 8, so I would get rid of it by subtracting 8 from both sides. So I have negative 7d is greater than 0. Next, I would divide. To get rid of something multiplied by negative 7, I would divide by negative 7. Remember, when I divide by that negative, I reverse the inequality symbol. So I have d is less than 0 divided by negative 7 is 0. Once again, if I'm graphing that one, I would put some numbers down as reference points. Since it's a less than symbol and not less than or equal to, I'm going to put an open circle at 0. And I'm going to shade. This says d is less than 0. So this would be less than. And the part that I'm shading is representing d. I could write it the other way, putting the 0 over here and the d over here. Notice it's opened up towards the 0, so we'd open up towards the 0. This says 0 is greater than, which is also represented by this. 0 is bigger than everything that we chose for d. And last but not least, problem number 11. Problem 11, we have 4a plus 6 greater than or equal to 7 plus 4a. We have no parentheses, no like terms. We do have variables on both sides, so we're going to add the opposite of one of them to both of them. So I'm just going to pick this one and do minus 4a from both sides. Uh-oh, on this one, all of the variables cancel out. So we need to see if we're left with either a true statement or a false statement. This is saying 6 is greater than or equal to 7. Is that true or false? That is false. Since it is a false statement, we're going to put that there is no solution. Remember, we can use that empty set symbol to mean that there is no solution to our problem. If we were to have solved the problem and gotten something that was true, like 7 is greater than or equal to 6, that is a true statement. 7 is greater than 6. If we had a true statement, then we would have put our all real number symbol. But for this one, it is no solution. Hopefully that's a quick review on how to solve equations and inequalities.